Hi, welcome back to Digital Forensics. We're going to carry on with Chapter 6. So we're going to look at current digital and forensics tools. So moving right along, let's see what we got. Explain how to evaluate needs for digital forensics tools. Describe available digital forensics software tools. List some considerations for forensics hardware and describe methods for validating and testing forensics tools. Now this is going to be split into two sections, part 1 and part 2. Depending on how fast we get through this, it's 52 slides there, and about slide 26 we finish one section, so we'll see. All right, consider open source tools the best value for as many features as possible. Questions to ask when evaluating tools: on which OS does the forensic tool run? Is the tool versatile? Can the tool analyze more than one file system? Can a scripting language be used with the tool to automate repetitive functions and tasks? Does it have automated features? What is the vendor's reputation for providing product support? Now, great questions there. The scripting language, if you're using PowerShell, you may have noticed PowerShell is a bit unwieldy. So if you're running PowerShell, you may run into some situations where you'll be typing 3 to 10 times more than you would inside of Bash. But nonetheless, it's good to know PowerShell, and it's good to know how to do those things. Another thing to note is with the hardware, if you're running forensics utilities, you plug in a hard drive to Windows, and Windows will write information to the drive. So you have to use a write blocker if you're using Microsoft Windows. That's another disadvantage to Windows. The file system support inside of Windows is also extremely limited, so you'll be careful about your file system support. You may not have the right system supported inside of Windows. Now, having said that, Windows provides an excellent platform for a lot of our forensic utilities. So we've already seen that with Autopsy, which, I don't know, probably developed for Linux to start with, and used to have the same interface in Windows and Linux, but now Linux only supports the big enterprise solution. It doesn't support the individual workstation solution. So, types of digital forensics tools. Hardware forensics tools range from simple single-purpose components to complete computer systems and servers. Software forensics tools types: command line applications and GUI applications, commonly used to copy data from a suspect's disk drive to an image file. Now, of course, we've been through the DD for the data dump, or the convert and copy, DD, to copy a drive over, which is a great way to do it. DCFL DD is a wonderful forensics utility that allows you to, as you copy it, put in a checksum on that file. So we've already looked through that. We may look through it a little bit again, but in this case, we're just going to discuss the tools out there. The following guidelines set up by NIST Computer Forensics Tool Testing, CFTT program, ISO standard 27037, states digital evidence first responders should use validated tools. Now, using validated tools is extremely important. Now, the tool being open source can aid in its validation, because then you can validate the open source software. Closed source software can also be validated, and that's because it'll be validated through mostly public use. So 5 major categories: acquisition, that is the DD utility, validation and verification, extraction, reconstruction, and reporting. So you'll notice that almost everything is going to use some version of DD to do its acquisition. The validation and verification, almost everything is going to use MD5 and SHA-256 sums for their validation and verification. Extraction, this is where we start looking at what we're getting off the disk, and that is wildly varied between different operating systems. Reconstruction, once again, big difference between systems, and reporting, big difference between systems. The reporting is going to be the most critical aspect in your final forensic analysis. Acquisition, making a copy of the original drive. Acquisition subfunctions: physical data, logical, data acquisition format, command line acquisition, GUI acquisition, remote, live, memory acquisitions. Different ways of looking at it and different ways of grabbing things out there. Acquisition: 2 types of data copy methods are used in software acquisitions: physical copying of the entire drive, logical copying of a disk partition. The formats for disk acquisitions vary from raw data to vendor-specific proprietary. You can view raw image files contents with any hexadecimal editor. And they're making a note there saying, hey, yeah, as you go through and you kind of look at which utility you're going to use, realize that if you have a raw file, a .img or a .raw, which we add the extension on those aren't automatic. If you have a raw file, you can go in and do the hex dump or the editing directly on that file. You can search that file directly. Whereas if you've got something in expert witness or advanced forensics format or some other format, then realize you may not be able to go through and pull information off that file directly. You may have to use another tool to convert that to a raw file, or you'll have to use their software to read that raw file. Okay, this is an example. This is using WinHex. We've used lots of different hex utilities in the Linux environment. Of course, you can get some hex utilities for the Windows environment as well, and that allows you to go through and pull information off. WinHex, great utility, so it's something that you can use if you want to. Creating smaller segmented files is a typical feature in vendor acquisition tools. So you get a 40 terabyte array and you want to split that thing down at 250 megabyte. Yeah, that'd be great. 250 megabyte parts, then okay, go for it. So, there are ways to split that kind of stuff up in DD, DCFL DD and D3DD. That is, or is it DC3DD? Those all support splitting the file up into multiple parts. If you do have one big file, then you can use the Linux split command. So just do a split -b, whatever your size is, 100 meg, that'd be 100 capital MB, the file, and then done. Or you can actually put the file prefix you want in there and then done, and it'll go ahead and split that up for you. Alrighty. So validation and verification. Validation, a way to confirm that a tool is functioning as intended. And this is where you'll find a lot of the free software kind of falls down. And that is the closed source and open source free software. It hasn't been validated. Autopsy and SleuthKit, they're well validated. They're extremely popular. But if you just go out and write some Python disk scraping utility, then, or a disk slicing or partition pulling or whatever, it's not going to be validated. So you need to have some type of validation on that. Now, what is validation? Well, NIST can validate, just because they'll have it in a research paper, or you can send it off to a bunch of forensics experts and they can validate it. But there really is no real validation. There's not some government committee that's over the entire world that says, oh yeah, this is a validated tool. So watch out for that. Verification provides that two sets of data are identical by calculating hash values. The related process is filtering, which involves sorting and searching through investigation findings to separate good data from suspicious data. Okay, validation and verification continued. We have the CRC32, MD5, SHA-1, and those are really common because they are lightweight. And so the CRC32 and MD5 and SHA-1 are going to be lightweight validation tools. They are not going to be as heavy as a SHA-256 or a SHA-512, which is going to provide you with a very solid verification and validation. So filtering based on hash value sets. So you can give it a hash value set and then run through and validate that information. We looked at that inside of Autopsy. Analyzing file headers, discriminate files based on their types. And the National Software Reference Library, NSRL, has compiled a list of known file hashes for a variety of operating systems, applications, and images. So the NSRL has a huge list. I think we've got that on the vault. It is massive, though. It is. It's going to be probably. I venture a guess, but I remember it was over a gig of just hashes. I'd have to go look it up to see how big it is. But there you go. This is welcome to their site. You can go through and download their stuff. You can import that, and then all of your applications will recognize all the hashes there. So many computer forensics programs include a list of common header values. That means that it's going to pull out files that it recognizes. We see this in Foremost when we do a Foremost recovery. Foremost pulls out PNGs, AVIs, whatever it finds, because it recognizes file headers. As new files are developed, those new headers have to be entered into the system, and it needs to know where the file starts and when the file ends. It can't figure out what a file is just by slicing a disk. So if you are a hacker or you're planting something, then you can just avoid putting a common file header on it. And you can put the information on a disk and it will not be found. It might not be found. Depends on what people are looking for. So right there, they give a file header indicating a JPEG file. And in this one, as they go through, they're trying to demonstrate that JPEG is referenced in the file. And that way it can tell that it's a JPEG and there's a beginning and there is an end. So for the file filter.doc cannot be opened because there are problems with the contents. This is an error message displayed when trying to open a JPEG file in Microsoft Word. And this is really with any operating system. However, it is really significant inside of Windows. Windows recognizes file types by extensions. Inside of a GUI on a Mac or a Linux box, they will also recognize files by their extension, but that's only a function of your file explorer. In class, we use Nemo as the file explorer, and it recognizes extensions. The systems, Mac and Linux systems, which I should just say Unix and Linux systems, don't look at file extensions from the CLI. They look at actually the file header and contents. So to find out, you would type the word file to see what it comes up with. A quick illustration can be performed from the command line if you have a Unix or a Linux box handy, which I'm sure everybody does with virtual machines. Then you can pop into a terminal. Inside the terminal, you could type file for any number of files there. So you can say file for a DMG file. It'll list what that is. File for a PCAP. It'll list what that is. And then for a more complex file type, we could pull out an ISO. And this is not a standard 9660 ISO, but an Apple ISO made for installing El Capitan. So you can see that Unix and Linux systems see the file itself for what the file is, not based on extension. We can move the files, which is renaming them, and we can call it like word.docx, and then run file with word.docx, and it will still recognize it as a TCP dump capture file. Those kind of things right there are important to keep in mind when you're on a certain operating system, that Windows does reference the extensions. Unix and Linux systems do not reference the extension except in the file manager, and that's to make things a little easier. So carrying on, this is that bayshot.docx opened in Paint. So giving you an idea of a file opened inside of Paint that had an extension of docx. Paint recognized it, and so it went ahead and opened it up. Extraction, recovery task in a digital investigation, most challenging of all tasks to master. Recovering data is the first step in analyzing an investigation's data. Okay, this is intense because when we're looking through the data, we have to figure out what we want to get. Now, we talked about the registry last week, and looking into the registry is a huge mess. There are thousands of entries that you can go through, and you could spend an entire year digging through the registry. You need to know what you're looking for, or you need to have the tools that allow you to search what you would like to find. So, subfunctions of extraction: data viewing, keyword searching, decompressing or uncompressing, carving, decrypting, bookmarking, or tagging. Keyword search speeds up analysis for investigators. So a keyword search can be built into something like autopsy, or you can do it from a grep from a command line. This is an example of OSF. So this OS Forensics utility, osf.exe, is available over on the Vault. You can install this. If you do, I suggest that you go ahead and put your machine into a snapshot, install it, because it's only a 30-day or a 7-day trial version. And then you can go through and you can look at some images there. If you want to grab some images, we have a huge number of images on the Vault over Volume 2, and those are forensics images. And you can pull down those images and see what kind of issues you have with extracting information from those, or what they contain in each of those images. Those are real forensic images. Some of them are real as in from the company Enron. and others have been used for real forensic challenges across the world. Okay, over here we've got some tasks. Deleted file search configuration, quality, excellent or good. They have case sensitive, include folders, match whole word only, multiple streams only, file carving slow, those kind of things. This is one of the things where you're finding deleted files and you can kind of get close to what you're looking for there. From an investigation perspective, encrypted files and systems are a problem. Many password recovery tools have a feature for generating potential password lists for a password dictionary attack. If a password dictionary attack fails, you can brute force attack. Now, dictionary attacks are a form of brute force, and we used to call those all brute force, but now dictionary attacks really are what we just call dictionary attacks. And so a dictionary attack, as we run through, is taking a list of passwords and trying all the passwords. The RockU word list is one of the most famous word lists for using in a dictionary attack. And okay, cracking things. If you have whole disk encryption, use LcomSoft. It's a Russian utility. It allows you to go through and pull the keys off the disk. If you're using something like Lux, which is that crypt setup that we use for encrypting disks in a couple of our classes, then you won't have the keys shared on the disk, but you can do a dictionary attack. However, the way Lux is set up, you will have to pull off a specific number of bytes using DD in order to perform the attack. So it's a little convoluted, but you can still perform the attack, a dictionary based or a brute force starting with nothing and going to 0, 1, 2, 3, A, B, C, D, etc., up until it gets to whole words, which is going to take a while. Reconstruction, recreate a suspect drive to show what happened during a crime or an incident. Methods of reconstruction: disk to disk copy, partition to partition copy, image to disk copy, image to partition copy, disk to image copy, rebuilding files from data runs, and carving. Okay, to recreate an image of the suspect drive, copy an image to another location, and just use whatever you want. Examples of disk to image copy tools: that's Linux DD, ProDiscover, and Voom Technologies Shadow Drive. The DD allows you to do disk to disk, or disk to image, or disk to many images, or image to disk. So you can use anything you want with that. One they should mention on here is they should mention Access Data's utility, which is free for download. So if you go to Access Data, you can download their disk imaging utility for free. That runs on Windows. Reporting: to perform forensic disk analysis examination, you will need to create a report. Subfunctions of reporting: bookmarks or tagging, log reports, timelines, and report generator. Log reports are when you're going through and you're actually performing something. It will log everything that you do. It's also finding logs on a system and then reporting on what logs you have found. Timelines: when a file was accessed on what system. This gets extremely complex when you get multiple systems. The multiple systems have to be verified that they are all in the same timestamp, which whatever that time zone might be. If they're not in the same time zone, then you'll need to switch them over to the same time zone, and usually that's done through just a calculation. This gets really annoying, and so reconstructing logs from several countries, if you don't have your system set up at GMT, then that is a bear. And you can script it, and you can write out a program that will go through and subtract the time and make it all the right time. All right, considerations. We're here: flexibility, reliability, and future expandability. Create a software library containing older versions of forensics utilities, OSs, and other programs. And the reason you want to create that software library is because many times the new utilities do not work the same way the old ones did, and they lose features over time. There's also the old Linux version, which only runs on old Linux systems, which looked exactly like the Windows version today. Runs as a desktop executable. That's gone now, and now you have to use the Linux version through a web interface. So will it come back? I don't know, maybe. But that's just a note that these utilities, as they come out, may not work on newer versions of Windows, or the newer utilities may not work in your current version of Windows or Mac or Linux. All right, hope that this has been helpful. I look forward to talking to you soon.